Today we are comparing four of the most popular tools for building user interfaces. While some are technically libraries like React and Solid, and others are frameworks like Vue, or even compilers like Svelte, they are all competing to solve the same core problem: how to efficiently keep your UI in sync with your application's state. We can see that when the application's state changes, the UI is updated accordingly. Although all four tools achieve the same result, they use different underlying techniques. Let's begin with React and explore how it updates the UI. We will use the same code across all four UI tools so we can clearly compare their behavior. Our setup includes the main app.jsx and two child components, user count and user list. In app.jsx, we have initial user state, toggle user to flip a user's active status, active count to compute how many users are active, the user count and user list components rendered with props. User count simply displays the active user count. User list renders each user's name and a toggle button that updates the state. So let's see a simple example how React behaves. So let's say we have an app state, an array of fruits, and we only have one item in the array. Next, our state changes and we have now two fruits in our array. At this point, our React's core idea comes into play. So when state changes, React reruns components from the top, builds a new virtual DOM and dips it against the previous one to compute the smallest real DOM updates. Think of the virtual DOM as a blueprint of the UI. React compares blueprints to update the page efficiently. Let's dry run our code and see what happens. Okay, so React goes to app.jsx, start from line 1, okay, reads, it sees a console log, goes to the console log, prints it, comes back, sees the user count and user list components, goes to user count component, runs it, sees a console log again, prints the console log to the console, comes back, run the complete component, goes to user list, again sees a console log, then again prints it to the console. Look here, our UI is still in loading state. It has not rendered the UI yet. Okay, so now it finished reading the code. It processes everything and finally it prints everything to the browser. So all these UI tools behave almost the same during the initial render. The real difference, the magic, happens after the first render when the state changes. Let's start by looking at how React handles state changes behind the scenes. Now, a user clicks the toggle button. As soon as it clicks the toggle button, React Engine goes to that particular button. Then it goes to the app.jsx, finds the toggle user function and runs it. So this makes a change to the application state. So now we can see that our state is changed. So now React will rerun components from the top to the bottom because state has changed. So it goes back to app.jsx again and now it sees the console log. So it prints it to the console, goes back, runs the complete file. Then it goes to the user count component. Here it sees the console log again. So it prints it to the console, goes back to user list. Here again it sees the console log. So it prints it to the console again. And then it runs the remaining part of the component. So now it comes back, it creates a new virtual DOM. We already have a old virtual DOM from the previous render. It dips both of them and finds the minimal change that is required, and then it goes and updates the DOM. So this is the process React follows to update the DOM, and this continues multiple times as our state updates. Now let's run the same example in Vue and watch what happens under the hood. We start with fruits containing one item. During the initial render, Vue wraps fruits in a proxy, tracks which components and computed values depend on it, creates the virtual DOM, and updates the UI. Now we add a second fruit. The array changes. Vue's proxy intercepts that mutation and immediately triggers only the dependencies tied to fruits. Vue schedules updates only for fruit list and fruit count. The app component does not rerun. For those components, Vue builds small virtual DOM fragments, dips them locally, and applies only the minimal DOM updates. Alright, now let's jump into the Vue code and see how it behaves differently from React. The initial render is already done. You can see all the console logs from the components on the screen. Let's pick it up from the moment the user interacts with the app when the toggle button is clicked. So the event handler from user list gets fired. It goes to the app.vue. Here you can see there is a console log, but it won't be logged to the console. Now it goes to the active count, and there it sees a console log, prints it to the console, comes back and updates the state. So now as the state is updated, the Vue engine sees it. Vue runs the dependent components only. So in this case, the user count. So it won't run the script setup again because it exactly knows what it needs to update. Now it goes to user list, runs the complete template, now comes back, diffs the old VDOM and the new VDOM, and does the smallest DOM update required. That's how Vue works. So here you can see it only ran the dependent components and we don't see the console logs again. Alright, great. Now let's move to Svelte. Forget about React or Vue. Svelte is completely different because it's not a framework, it's a compiler. A compiler converts your code into another form that the next platform can understand. That's exactly what Svelte does. It takes your .svelte file and turns it into plain optimized JavaScript that the browser can run directly. Once the compiler runs, your Svelte code is gone. The browser never sees it. It only executes these pre-written DOM updates, which means it already knows precisely what to change when something updates. No virtual DOM, no diffing, and no re-rendering. We won't be dry running our code here because the console logs will behave exactly the same across Svelte, Solid, and Vue. All of them efficiently update only what changes in the DOM. just their underlying technique is different. Finally, let's see how Solid.js works behind the scenes. Just like Svelte, Solid does not use a virtual DOM, but it's not a compiler either. Instead, Solid is a reactive runtime library. That means your code runs in the browser as is, but Solid sets up a reactive system that automatically tracks which part of the DOM depend on which values. Sounds complex? Let's simplify it with an example. Let's start with a simple counter. When the component first renders, Solid sees that the text node inside the button depends on count. So it builds a small reactivity graph like this. That means whenever count changes, update this text node. So when you click the button, the DOM updates directly. No re-render, no diffing, and no compiler step. The reactive graph may contain hundreds of signals that update the DOM based on user input. This is how Solid.js works.